roller no at one point at the other end. So if mo expand na siya class, mulihok na imong bridge or mudagan imong ligid no at in this manner. So minimal lang pud kayo na siya nga movement. It's just that mura bitaw og muginhawa lang gid si bridge no. So let the bridge breathe. Ana lang siya. So if i-restrict man gud nimo siya nga movement class, so there will be or mag-generate na siya og internal na stress no sa toang structure which may cause failure sa toang structure. That is why to address that one, no to eliminate internal stresses sa toang structure, so ato nang gina-accommodate nga expansion. Okay? So ang hinge end or pin support. So, mo pa niya ang iyahang actual ng application. No? So, kaning first figure, this one, this is actually a connection of your arch beam. So, kanang mga arch beam that is famous sa kanabitong if tagpas kayo ang span sa imuhang column, ang imuhang distance sa column. So, basically, makita nato na siya sa churches no, or sa cathedral if nakasulod mo sa or if Catholic mo no, and nagasimba mo dira sa cathedral, then manotice nimo nga ang ato ang beams no is actually naka-arch actually siya. So this one naman kaning last figure mo ni siya si hinge support no and naka-incline di ba siya. So ana lang siya class no ang iyang application. So for fixed support class no, so this is considered di ba as the rigid type of support. So isa din siya ka example no ang kanang footing sa imong structure or sa flagpole pwede na siya ma-consider na siya no as fixed support. And then for steel like for this one kaning akong gi-circular no, so if welded connection na siya then that is considered as fixed connection and under na siya sa fixed support no. So when you say fixed support class no in concrete, it must be so at least connections ni siya class no. Dara nag-exist ato ang fixed support connection sa imuhang column and beam. And if that is the case class no, your method no in conoletic nga system class dungan no ang pagbuhos sa imuhang concrete sa imuhang column and sa imuhang beam. Okay? So although karon we have a newer method which is kanang mga precast na lang bitaw nga mura na lang kaog nagpuzzle nga i-assemble na lang mga concrete, but as to the cast in place nga condition class or nga system, it has to be monolithic class no to secure or to obtain solid bond bitaw sa imong connection nga part class sa imong beam and column. Okay, so for the basic types of beams, we have what we call simply supported na beam or simple beam. No, so ang simple beam that is just actually a hinge at one end and then at the on the other end sa imuhang structure or sa imuhang beam naka-roller support na siya class no. So just like bridges. So cantilever beam. So sa cantilever beam class no, we have this like for example mo ni ang ato ang beam and mo ni ato ang surface no, or wall. So at for cantilever beams class no, fixed support ang ato ang ginagamit ana. Okay, then one application of this, if you notice, kanabitang sa mga buildings class no or sa mga structures, nga naay mga terrace nga naka-protrude, di ba? Mura ginahimo og terrace kana sila o let's say for example, this is a side view, no? Oops. So, di ba? So, muna siya itong mga ginatawag nga or one application of a cantilever beam. So, take note ha nga, when you have a cantilever beam, at one end lang siya supported. Then, for overhanging beam, this is just actually a simply supported beam with extension, no? Or extended ang iyahang other end or both ends, no? So, if na overhang at at both ends or at both supports, then that is also considered as overhanging a beam, or at one end lang. So that is also a case of overhanging a beam, no? So fourth type of beam, we have what we call prop beam. So this is actually mura lang ni siya og cantilever beam class, but um, supported ang iyahang other end, no? So fixed support and then roller support at the other end. So this is called a prop beam. Or if na siya extension diha class, then this is called as overhanging prop beam. Okay? So there are actually a lot of classification or types of beam. It's just that ang akong gi-present sa inyo is the basic, no? Kaya ang the rest of the beams na dayon nga classification is just a combination of these basic na mga beams. So for restrained beam, so from the term restrained, both ends are actually fixed support, supported by a fixed condition nga support class. Okay? But kaning prop beam and restrained beam, these are actually statically indeterminate nga mga beams class. So when we say statically indeterminate nga beam, unsa galatong pasabot? Manawag ko ha. Wala may mag-volunteer. So, Miss Jovi Kailing.
Sir,
When we say statically indeterminate na beam or na structure, unsa gali ato ang pasabot ana?
kuan sir, two ang unknown reaction, then isa lang ang known reaction.
Well,
Or
basically, yeah, tama no? But the concept is, if dili na enough ang equations of equilibrium to solve for the unknown forces, then we will have a statically indeterminate na structure. Okay? So, inana lang ang iyahang concept class. And how do we solve or how do we solve for statically indeterminate na mga structures? Any idea? Anyone from the class? So, di ba, sige nga nato ni siya ginabalik-balik from stress and strain nato na topic. So, unsa galito atong approach kung naatay statically indeterminate na structure. So, unsaon man nato siya pag-solve? So, Miss Janiel Beniga, or anyone from the class, may idea? Displacement method, sir? Yeah, actually, that is a very specific nga answer, no? So, thank you for that, Mr. Econar. So, to solve for statically indeterminate na mga structures class, no? We have to relate the geometric deformation of your structure. So, we need additional equations, diba, to solve for the unknown forces. That's why we need to create or to generate additional equations. And by relating the geometric deformation of our structures, then makakam up taog new equations, no? Or what we call the equations of compatibility. Diba? Ato naman na siyang na-discuss before. However, class no, in engineering, rather in mechanics of deformable bodies, dili na ni siya part sa ato ang scope. So our scope lang here in mechanics of deformable bodies is that ang atong consideration lang or ato lang i-consider is kaning mga statically determinate na mga beams, no? So, ang kanada yung statically indeterminate na mga beams, dito na ninyo siya ma-encounter sa theory of structures, no? So, itagaan lang tamo og overview no, of what's ahead of you. So, after mechanics of deformable bodies, then if makapasar mo ani nga subject, no, then next in line would be si theory of structures. And then sa theory of structures, isa ni siya sa inyong topic, no? Isa ni siya sa inyong mahimo nga topic ang statically computation or solving for the shear and moment diagrams of statically indeterminate structures kay you are to relate it ano man, elastic deformation. Kaya di ba nag-ingon ta nga, if ang ato ang approach in solving statically indeterminate structure is to relate its geometric deformation sa structure. So sa beam pod, no, sa ato apong statical indeterminate beams, we are to consider the elastic deformation of our beams para makakuha ta og additional equations, no. Then eventually ma-solve din nato ang unknown forces in statically indeterminate na mga beams. Okay? Sige. So, in solving shear and moment diagram class, no, we actually have two methods, no. So, today, for this session, ako i-introduce sa inyo ang first method, which is called the shear and moment equations. So, next week, no, or sa to ang next meeting, we will discuss the other method naman. Okay, so for today, ang ato alang agenda is ang kaning first method called the shear and moment equations. So, because of the applied external forces class, no, the beams tends to develop an internal shear force and bending moment that in general vary from point to point along the axis of the beam. So, anong importante ba na siya sa ato? So, this is very important class, no, in order for us to design a beam that is necessary to um, resist, no, those shear and moment or bending ng mga reactions class. So, if ma-determine na to ang maximum shear and maximum moment sa to ang beam, then ma-project na to, no, or maka-design ta og appropriate niya na dimension and reinforcement na dayon class, no. So, mo na yung importance sa ato ang shear and moment na diagrams. Okay? So, before ta mag-solve, no, ato lang sang istoryahan ang sign convention of shear and moment nga equation nga method. So, if shear and moment equation nga method ato ang gamiton class, ang ato ang approach in solving problems is that mag-cut ta class og points, no, at certain points sa ato ang segment sa ato ang beam. So, if mag-cut di ba ta og section sa atong structure, di ba ma-expose man ang iyahang internal reactions. So, which is in this case, na-expose ang iyahang internal shear and ang iyahang internal moment. So, it says here that the positive direction are as follows. So, positive ang direction sa to ang internal shear if it causes clockwise rotation of the beam, no? Sige. So, let's say for example, nag-cut ta og plane, no? Then we are to consider left side sa to ang structure. So, with respect to the support here, so unsa man nga direction sa shear ang mag-cause of clockwise rotation. So, di ba, it is downward nga direction. So, if downward direction imong shear with respect to this support, so it will have a clockwise rotation. Okay? Then, similarly, if we are to consider the right side part of our beam, and then with respect to this support here, so unsa man nga direction of shear mag-cause of positive or rather clockwise na rotation. Diba upward direction of shear force, it will have a clockwise rotation with respect to the support here. That's why in short class, no, or in other term, if mag-analyze ta sa to ang beam left side ang ato i-consider sa tong analysis, then your shear force or your internal shear force is acting downward. Okay? Then, similarly, if right side ang ato ang i-analyze ato ang beam, then the direction of your internal shear is upward. Okay? So, sa moment, so it says here that the positive direction of a moment or the internal moment is that it causes compression in the top fibers of the segment such that it bends concave upward. So, if we are to analyze left side part of our beam, so if we have this direction of your moment, which is counterclockwise, di ba, that tends to bend your beam in this manner. So, if natay na nga bending, so ni ni qualify siya no sa atong criteria for a positive direction of internal moment, which is concave upward, and then compression ang iyang top fiber because class, let's say naataan ni nga beam, no, so ang topmost fiber nato, and if mo bend na siya in this way, so the topmost part class na of your fibers are actually under compression, and then the bottom part that is under tension. Nasabtan ba? No? Unta na imagine ra ang nahitabo sa structure nga if ato na siyang i-bend, ang bottom part mainat na siya, di ba class? Then ang upper part sa imuhang beam is ma-compress na siya class, no? Okay? So this is actually ang ato apong basis bitaw class sa placement sa ato ang reinforcement sa beam. So sige lang, maabot ra mo ang topic no sa ato ang mga structural nga mga subject na design. Okay? So isa ni siya nga basihan or concept no in determining the placement no of your reinforcement steel sa isa ka beam class, no? Kay di ba ang steel, it is for tension. Kay ang ihamang strength is for tension, and then ang concrete, ang ihapong strength ana is compressive po, no, or your concrete has high resistance to compression class. And similarly, your steel has high resistance to tensile nga forces class. That is why nga um, we have what we call the reinforcement concrete. Okay? So, take note ha nga, concrete is different from reinforcement concrete class. Kay concrete, when you say concrete, concrete alone lang na siya, no? So, cemento, then aggregate, so mixture of a material class, no? But when you say reinforced concrete, so naana na siya mga kabilya involved. Okay? So, importante na nga makawalamuan ang terminologies kayo or civil engineering students ra ba? Okay, so I hope klaro ang sign convention no, sa ato ang internal shear and moment sa pag-cut sa ato ang sections. Sige. So, to better illustrate the concept no, of shear and moment diagram, the shear and moment equation, let us solve sample problems. So, for situation number 1, we have write the shear and moment equations for the sige. So if you're wondering nganong mga problems here no in mechanics of deformable bodies class is mostly neglecting the weight no of the material, that is because class mechanics of deformable bodies is focused on the external the application consider ang properties sa material. So external loadings or the applied loadings ang ato ang mura og focus nga gina-consider. But don't worry kay pag-abot sa inyohang structural design ng mga subjects, i-consider na ang properties sa inyohang material class, then maka-design na dayon mo ana. Okay? So introductory lang ta na part. So concept. Okay? Sige. So, di ba, this is a simply supported nga beam. Ala, for a while kay nawala ang magnitude sa applied moment at point B. Wait ha, tanawon, i-check sa ako akong reference. Okay, so the applied moment at point B is 12 kilonewton meters. Okay. Sige. So, we have this given loading, di ba? So, first step is, of course, compute or solve for the reactions at the supports. So, at point A, di ba, that is a hinge support, meaning it has two reactions. And then at point C, roller support, so one reaction lang no and perpendicular to the surface. So for ato siya i-label as AY and AX, and notice that sa atong external loadings na wala tay force or walay loadings that is on horizontal or acting horizontally. So meaning, this is AX. your AX no, or horizontal reaction at point A class is just equal to 0. Okay? So this is CY. Sige, so let us solve for the reactions at both supports. So unahon ako si AY. So to solve for the reaction at point A, so we will take moment at point C. No? At roller support. Kay roller support, diba, they don't have resistance to moment. That is why summation to moment at summation of moment at that support is equal to 0. Kaya wala man siya resistance to moment. So, summation of moment at point C equal to 0, having counterclockwise as positive. Sige. We have here AY, no? AY will be causing clockwise rotation with respect to point C, meaning negative sign convention. AY times moment arm na 8 meters. Then, si distributed load, no? Okay, first class, let us convert the distributed load into concentrated load class na or the pointed load. So, ato siyang i-convert. And what is now the magnitude of our distributed load? So, di ba, it's just 8 or the magnitude of your distributed load times the span, no? Kung asa siya nag-act, which is 5 meters. So 8 times 5, di ba, that is 40. So the resulting unit would be kn. Kay, di ba, 8 kn per meter, then 5 meter, mag-cancel ang meters. So 40 kilonewton ang ato ang um, resultant force no for this distributed loading class. And then location, asa man ni siya located, di ba? Your resultant force should act at its centroid, no? Sa imuhang distributed load. So meaning, since this is just rectangular nga loading, no? Ang imuhang location of your resultant force from point B or from point A, it's just 2.5, no? Katunga lang ni 5 meters class. Na siya sa center nag-act. Sige. So now, continue to sa to ang summation of moment at point C. So you have AY and then unsa pa man nga force involved, so si R, no? And your resultant force of your distributed load will act or will cause counterclockwise with respect to point C. That's why positive sign convention times moment arm 2.5 plus 3 meters and that is 5.5, di ba? So, unsa pa may laing involved. So, take note na you have an applied moment at point B. And we are taking summation of moment no, at point C. So, for the whole structure, we are to consider the applied moments also. So, since ang ato ang sign convention no, is positive ang counterclockwise nga direction or nga rotation and this is a counterclockwise rotation. So, plus 12. No? So, dili na nato na siya i-multiply sa kuan class ha. Moment arm. Kay that is already a moment naman. So, dili na nato na siya i-multiply sa ihang moment arm. Okay? I hope that's clear. Then, unsa pa may involved na forces? Wala na, no? So, si AY, si R, and ang applied moment lang no at point B ang involved sa itong analysis. So, in this equation class, AY lang ang unknown, di ba? Therefore, masolve na to siya directly. So, R is 40 kN, di ba? Therefore, your AY, if ato ni siyang i-arrange class, no? Or i-transpose na to siya to the right side part of our equation, ma-positive na siya, no? Then, divide both side by 8. Plus 12 over 8. Therefore, AY is how much? 29 kilonewton. Okay, so nanatay vertical reaction no at point A. So si CY. So, to solve for CY, dali na lang, no? Pwede na lang taari mag summation of forces, vertical equal to 0. Or pwede sad na mag-take mo all moment at point A. Actually, class no, kanabitang kanang ang kaning pag-solve bitaw sa atong reaction, it is actually much safer if submission of moment ang imuhang gamiton. Kay nga no, kay if like for example, di ba in this case, na-solve na nato si AY and then ang ato ang pamaagi sa pag-compute or pag-calculate kang CY is summation of forces vertical. So, kani siya nga equation class, dependent ni siya sa ato ang result nga na-compute at AY, no? So, what if lugar nga sayop ang imong na-compute na reaction kang AY. So, masayop na po ang imuhang reaction kang CY and then mag-domino effect na rin na siya no, for the rest of your solution. Unlike kung summation ka og moment at point A, then makonsider nimo tanan forces class no, which is makuha gyapon nimo ang correct nga value for the reaction at CY no. But for this case, kanilang nga to ang buhaton no. Either way, it's just that make sure lang no nga sakto po ang imuhang solution kay para dili ka masayop bitaw sa imuhang preceding calculations. Okay, so AY is upward. So taking upward direction as positive. So AY plus CY minus CR, no? Equal to 0. Kaya wala na may laing forces no involved in y-axis, no? So dili na to i-consider ang moment at point B. Kay dili man na siya force, that is a moment. Okay? So AY is obtained, R is also obtained, which is 40 kilonewton. Makompute na to actually si CY. And how much is CY? So if AY is 29, then R is 40. So that would be CY minus 11, no? So if i-transpose na to ang 11 sa to ang right side part sa tong sa equation, then we'll have a positive value for CY, which is 11 kilonewton. So there, na-solve na nato ang reactions no at both supports. Sige, so I hope class ha nga master na mo mag-compute and mag-calculate sa reactions at supports. Kay mo gina ato ang mga first steps at ang mga solution class. Now, let us now determine the equations no for shear and moment at our beam. So in this case class, excuse me, unsa man na to ang unsa man na to ang condition no para mag-take ta og or mag-cut of plane, no? So how do we determine if asa ta nga point or nga segment mag-cut of plane? So that is actually class if there is discontinuity. Okay, take note of that. So when you say discontinuity, that is a change in magnitude of your force, no? So notice class na from point A to point B, so constant lang di ba ang imong force? And then at point B na-apply nga moment. Therefore, at point B, there is change in applied forces and moment no at the certain point. That's why kata diri nga point. So segment A to B and then continue ta sa to ang pag-examine or pag-test sa to ang beam. So from B to C, so constant lang dayon siya no. So walay loadings nga applied sa segment B to C. That's why class in this problem, we'll have to cut plane at two segments. No, we have two segments of consideration. Okay, so mag-cut ta kang A to B and mag-cut po ta kang B to C. Okay, para determine na to ang iyahang internal reactions no at both segments. Sige, so unahon na to si A to B. So let's say mag-cut ko diri nga point or nga part. So ang imuha bitaw dayon i-consider class no nga side is of course katong convenient bitaw no or mas dalian kapag solve. So for this case, di ba, if right side ang atong i-consider, we have a lot of forces to consider, no? Daghan to og i-consider nga mga reactions or forces. So it is much easier for us to analyze it if left side ang ato ang tan-awon sa ato ang cutting plane, no? Kay kanila mang distributed load and then the reaction at point A. Okay? Sige, so with that being said, let us analyze section or rather segment A to B.
So while you are doing your rule right now,
So, di ba, we are to consider left side part of our beam. So, sa left side nga part sa itong beam, ang atong makita is ang reaction at point A, which is si AY nga 29 kilonewton. And then, ang distributed load.
up to 5 na. 430 lang.
Okay. So, ang magnitude sa ito ang distributed load is 8 kilonewton per meter, di ba? Sige. So, meaning class, if magkatag plane, di ba, ma-expose man ang internal shear, an internal moment no, of your segment. So, meaning, balik ta dito sa ito ang concept no, sa sign convention. So, if we are to analyze left side part of our beam, di ba, ang shear na to is acting downward and your internal moment is counterclockwise nga direction. So, ato na siyang i-follow lang. So, this is V or the internal shear at this segment and then the internal moment at this segment also. So, our goal is to create or generate no an equation for shear and moment no for this segment class. Sige. So first, establish po na to ang distance, no? Unsa man ni siya nga span. Since nag-cut man ta and we don't know if asa ta nga part, no? Or pila ang distance ani nga span. So let us just set it to x. No? Ato lang siyang express as x distance. So our reference class, no, in taking distances of x, it should be from the left part of your support or from the left support. So, yung una tong reference, si point A, no, or ang left support, kani siya class, no? Then, your x distance should be from your reference point, which is si point A, in this case, no, or ang left support na to, until at the cutting plane, no? Muna ay muhang x distance, no? So, if mubalhin ta og x distance, or rather, if mubalhin ta og cutting plane class, no? Like, for example, kang BC, if we have this cutting plane kang BC, so your x would be this one na dayon, no? From the reference point up to the cutting plane. Okay? So, ina na ang ato ang condition class. Sige. So, now, we now have this a free body diagram no, of our cutted section or cutted plane. So we are now to create or solve for the equations no, of V and M. So by the way, no, represent na to ang internal shear as V and ang internal moment as M. Sige, so how do we solve for this? So of course, we will just apply the equations of equilibrium. So summation of forces on y-axis equal to 0, taking upward direction as positive. So upward si 29 kilonewton, so positive. So we will also convert this one, no, si distributed load into concentrated nga load. So si R. So how do we determine R? So it's just, di ba, the magnitude, which is 8 kilonewton per meter, times the span no, of your distributed load, which is in this case x distance. No? So meaning class, your R is just equal to 8x. Okay? So downward direction, so minus 8x. And then CV, no? For the internal shear force. And downward mo yung direction, so minus V. Equal now to 0. Kaya wala na may laing force, no? sige, so simplifying, we now have an equation for our shear force, no? For our internal shear at segment A to B. Okay? So for moment, so by taking moment at the point of cutted plane, so kung asa ka nag-cut dito ka mag-moment, so at this point, equal to 0, having counterclockwise as positive. So 29 kilonewton will have a negative sign convention times distance, no? So yung moment arm is x plus r. So sorry, ako na lang i-substitute directly ang value of r, which is 8x. So plus ang convention because it will create counterclockwise rotation with respect to this point, okay? Times the moment arm, no? Distance. So if this is x, so location of that is just, diba, x over 2. Okay? So this is x over 2. And then, wala na, no? So sila lang ang ato ang i-consider sa ato ang moment. Then plus m, the internal moment, no, at this segment. So, positive sign convention, since this is counterclockwise rotation nga direction, and we take positive ang counterclockwise nga rotation, no? So, equal na to 0. Therefore, class, naana po da yung equation of the moment. So, simplifying, we'll have 29x minus, so simplifying this one, this is 4x squared, no? Okay, so we now have shear and moment equations for segment A to B. So meaning class, no, your values of your x here in this equation, it should only be limited to value of x is equal to from reference point up to point B. Meaning, if in terms of distance, that is 0 to 5. No? Nasabtan, ha? Naka-follow ba? So, since si point yung ato ang reference point, no, then at segment A to B is 0 to 5 na siya, no. So your value of x should be 0 to 5 lang. Okay? Meaning class, no, if i-substitute na to ang values of x in these equations, then ma-determine na to, no, ang shear and ang moment at that certain point, no, or at that x distance. So this is actually the advantage of shear and moment equation nga method class. Ma-determine mo at any given point or at certain points, ma-determine mo ang moment at ang iyahang shear using the equations for that segment. Okay? So, by next meeting, i-introduce po na ako ang another method, no, in solving shear and moment diagram. So, for now, kami sa ito ang i-consider, no, equations. Sige. So, since we now have equations, no, for shear and moment in segment A to B, proceed na punta with, segment B to C. Sige. So, let's say mag-cut ko at this point or at this section. So, di ba, mas easier or mas dali if we analyze na to ang right side part. No? Kaya if left side, so daghan tag i-consider ka po na force. Although, that is also possible. It's just that mataas ang atong equation or ang ato ang solution. So, sometimes class, no, mangita lang taog ka na bitong convenient sa atong part kay sa word exam class, no, kay dili limited ang time. Dili ka tagaan og luxurious time, no, nga you have how many minutes to solve a certain problem lang. That is why it is much better to practice as early as now if asa nga ruta ang mas dali kabali na solution, no, without compromising the principles na of the topic. So, mura ra bitaw na og traffic sa syudad. So, if for example, si Cagayan de Oro City. So, if taga Cagayan ka, kabala na ka na kung asa nga part or asa nga mga dalan ang traffic kaayo. So, imubuhaton, di ba, is Bulikay. So, If dili po ka taga dinhi, so if baguhan pa lang ka sa Cagayan de Oro, wala ka idea no kung asa nga part ang mga heavy traffic, which is if I may relate, mao na ang inyong situation karon no, kay this is a newly introduced topic on your part man. That is why I am encouraging everyone to practice really problem solving, kay para through problem solving man good class no makagain og experience. Then over time pag mag-solve na mo og mga share and moment using those experience, kabalo na mo no kung asa ang much easier nga ruta kibali ba no. So ana lang siya, sige. So for segment B2C, wait, let me just add another blank slide. For segment BC. So take note class ha nga, these equations are only valid for values of x ranging from 0 to 5 meters. Okay? So for segment B to C, ang ato adi bang i-consider is left side part or right, or rather right side no sa ato ang beam. So we have this free body diagram of our cut section. So si roller support and then your reaction nga si CY, which is 11 kilonewtons. So na-expose no ang iyang internal and internal shear and moments, di ba? So we are taking right side sa ato ang beam. So from sign convention, if mag-analyze the right side part, then the direction of our internal shear is upward and the rotation of our internal moment is clockwise rotation. Okay. So, sige. So, sa given figure, wala na may lain load no, applied. So, sa right side, na analysis, so si 11 kilonewton lang ito ang concern or ato ang i-consider na force. Sige. So, let us establish the distance. So, di ba, akong gi-mention earlier that our reference point, which is the left support, then dira magikan no ang measurement sa ito ang x. So meaning class no, from left support, from our reference point until kang cutting point or cutting section, that is the distance x class no. So if this is x, so how much is this distance no from point C to the cutting section? So it's just the total length of your beam minus the value of x no, or in this case total span sa tong beam is 8 meters, diba? So 8 minus x. Okay, so total length minus x. So muna ang ato ang distance no at this region. Sige, so if that is 8 minus x, so this is 8 minus x na distance class. Okay? Sige, so applying the equations of equilibrium, summation of forces vertical equal to 0, taking upward direction as positive, then you have positive V, kay upward man yung direction, then plus 11 kilonewton equal to 0, since wala na may lain forces involved. So therefore, class, no, you have V equal to negative 11 kilonewton for segment B to C. So that only indicate, class, that you have a constant value of internal shear for segment BC sa imuhang beam. Okay? So constant lang ang iyang internal shear all throughout the segment BC. Sige, so for summation of moment at the cutting plane equal to 0, taking counterclockwise as positive, then you have negative m, no? Kay clockwise rotation man na nga to ang m here. And then si 11 kilonewton will cause counterclockwise rotation. That's why positive sign convention. So 11 times moment arm padulong sa to ang point of consideration. So 8 minus x equal now to 0. So if i-transpose na to ang M class, now we'll have this equation or simplified equation. 11 times 8 is 88, no? Tama ba? 88 minus 11x. Okay. Now, take note that these equations of your shear and moment only valid for values of x equal to Wheelman class. So if to ang reference point, di ba, is si point A, so B to C. Dara lang valid ang atong equations, no? Kay for segment B to C man na siya nga internal reactions. So in terms of x distance, that is 5 to 8 meters. Di ba? So from 5 meters to 8 meters. Okay? So mo na to ang boundary condition class sa to ang equations. Sige, so let us now plot the shear and moment diagram class using the equations nga ato ang na-obtain. Sige, ato lang sang i-copy ang figure.
Describe the parameters and which define protocol for also describe
For a while lang class ha, let me just so here we each.
and then discuss the different components of protocol.
Okay, so at point B also, so these are the important points, di ba, sa to ang analysis. So this is for the shear diagram or ato siyang i-denote no as VD. And then for moment diagram, si MD. Sige. So before ta mag-plot no, ako sang i-introduce sa inyo ang ato ang consideration no in a degree of slope. So let's say for example class you have a 0 degree or 0 degree. So your graph there will just be constant, no? Or horizontal line lang class. So if you have 1 degree, then we have slope, no? Or padipod in ani. For second degree, so that would be parabola na graph class, no? Or it could also be concave upward or concave downward. So depende na siya sa nature sa ato ang figure, no, or diagram. So on and so forth. So for third degree until nth degree, so curve lang yapon na siya, no? It's just that for third degree mas mugamay na siya gamay class. Ana lang siya. Okay? So similarly, mo po na to ang buhaton diri class no sa ato ang approach. So if sa ato ang loadings, no, you have straight line or 0 degrees, then your shear diagram mag ano lang ka class, no, mag plus 1, and then for moment diagram plus 1 yapon ka. So meaning if a 0 degree ang imong loadings, then at shear diagram you'll have first degree, no, or ang imong graph ana is sloping a line. Then pag abot sa moment diagram for segment A to B, so it will have a second degree plus 1 na pod, no. Okay? So for no loading, so nani siya preliminaries pag class, no. So before si 0 degrees natay no loading or no magnitude, no. So like for this case kang BC wala di ba loading, so pag abot sa imong shear diagram ano lang yapon ka class no, next na po di mo AC 0 degrees. So constant lang. And then after shear diagram, kang MD or kang moment diagram, mag plus 1 ta, so 1 degree. So 0 plus 1, so you have 0 degree. So sloping ato ang graph. Okay? So actually, daghan og convention as to how to plot the shear and moment diagram. But sige lang, later I will also introduce an easier method to determine the graph, no? Sa ato ang shear and moment diagram. Okay, sige. So let us plot the shear diagram first. So for segment A to B, so of course, ang ato ang basis is the equations no, of the shear diagram or the shear force at segment A to B. So kani si 29 minus 8x. So having that equation, so if we are to plot the shear at this point, at point A, so unsa man ato ang value for x? So pila ba na atong i-assign na value of x to plot no the shear at point A? Anyone? Any idea? Okay. 29. Yeah, tama actually, no. I think that's the answer already. But I'm asking if what value of x ang ato i-consider. So anyway, the value of x nung ato i-consider at point A is of course 0, no? So x is equal to 0. Kaya ang ato mang reference is si point A. Therefore, your distance at point A or the x distance at point A is just equal to 0, no? So substituting that to our equation for the shear, for the internal shear of point A, you have 29 minus 8x or 29 minus 8 times 0. So you have 29, no? So meaning class, positive 29. So taking this upward direct or the upward region as positive values, then the downward region as negative values. So positive 29. So you have here 29. Okay. So at point B, let us determine the location or asa na to siya i-plot, i-locate ang shear force at point B. Sige, so how much would be the value of x if ang point B ta mag-analyze? Pila man class? Any idea?
5, sir.
Okay, tama no. Kanang 5 ang atong i-consider nga distance ato ang x or value of our x. So substituting that value to our equation for shear nga 29 minus 8x. So 29 minus 8 times 5, that would be negative 11, di ba? So meaning class, naana siya diri nga part, no? Kaya we take downward region of our graph as negative values man. So let's say na-address si negative 11. Sige. So now, unsa may nature sa ato ang graph, no? How do we connect these 2 points? So, di ba, we have 0 degree sa ato ang loading for A to B. So, pag abot kang shear diagram, no, mag plus 1 degree ta, so it will have this first degree nga graph. So, i-connect lang nato siya, no? So, nakaslope lang siya. Okay? Sige. Now for segment B to C, kung sigala ito ato ang shear for segment B to C, so dili siya equation, no? It is a constant value, which is negative 11 kilonewtons. So, meaning class, constant lang na ang imuhang internal shear at segment BC class. Sige. Okay, so this is also negative 11 kilonewtons. So this is now, wait lang, kahiwi gid siya.
KLV. Yeah. Okay. So yeah.
So now we now have the shear diagram, no, for our given loadings. So, one indication nga sakto na nga to ang diagram is nag-close, no, na nga to ang shear diagram. Let's say, for example, di ba, at point A, na siya upward direction nga reaction. Si AY is 29 kilonewton. Meaning, if from point 0, musa ka to 29, di-connect siya sa to ang graph, di ba? And also, wait lang ha. At negative 11 nga point, then di ba we have reaction at point C also, nga upward direction, with magnitude of 11 kilonewton. So meaning, from negative 11, masaka pa og 11 kilonewtons, no? So that would be equal to 0. So negative 11 plus 11, mag-0 lang siya. So nag-close, no, ang ato ang graph. So that is very important nga mag-close na siya, class, kaya that is your indication na sakto ang ato ang analysis. So the important is the moment diagram, magsirado gini siya. Now, let us now graph or plot, no, the moment diagram for this given external loading. Sige. So for A to B or segment A to B, we have equation for our moment in that segment is 29x minus 4x squared, no? So what values of x ang atong i-substitute here? So again, so if i-plot na to at point A, so asa nakalocate na ato ang moment at point A, so ato lang i-substitute, value of x is equal to 0. Kay in terms of distance, point A is x equal to 0, di ba? So 29 times 0 minus 40 squared, that will just be equal to 0. So meaning, class, no, at point A, you have here 0 moment, no, or 0 bending siya. Sige, for point B. At point B, so di ba atong i-substitute na value of x for the equation is 5 meters para ma-determine nato, no, ang magnitude, no, of the moment at x distance 5 meters or at point B. And that is 45, no, positive value of 45. So let's say na siya na rin na point. This is 45. Now, unsa may ato ang nature of the graph, no, or unsa may itsura sa ato ang graph ani, class, no? So take note, class, ha, every time bitaw na mutabok ang ato ang diagram or ang ato ang graph from a 0 nga axis, you have to establish that point. You have to determine this point actually. Okay, so we need to calculate, no, if how much pod ang moment at this point, class. So how do we determine? So ato siya express, no, as distance A. So if this is from point A, or rather from left support until this point, wala man ta kabalo if pila na siya nga distance, no, but we can actually obtain that one by ratio and proportion, class. So kita mo ani nga triangle. So by that, we have this big triangle is to small triangle, meaning the altitude of your bigger triangle or kaning red, no, nga triangle, that is 29 plus 11. Kasi 29 is from 0 man na siya, class, no, at this point. So plus 11, so makuha na to ang altitude sa to ang triangle, that would be 40, no, over the span or the length, no, of your triangle, big triangle, which is 5 meters. So over 5 is equal to ang atong kakaon, diba, is si A. So smaller triangle, we have this part here, and that is just 29 over A. Therefore A is pila man na siya. This is 29 times 5 over 40. You have 3.625 meters. Meaning, class, no, from left support until 3.625 meters, dara nag zero shear, no? So walay shear din ha nga point. And actually, class, no, at zero shear, that dara po nag-exist na point ang maximum bending. Okay? And ato na siyang ma-confirm here. So, sa equation sa moment, no, for segment A to B, atong i-substitute ang value of x distance nga 3.625. So, 29 times 3.625 minus 4 times 3.625 squared, you have 52 point, or you have a moment equal to 5625 rather. So, higher than 45, diba? So, let's say na siya dari nga point. Okay. So, i-delete lang na ako aning kuan class para ira kayo siya gubot. Okay. Now, what would now be the convention, no? Or the direction of our graph? So, ako itudlo sa inyo mga style class is this one. So, ato lang siyang i-replicate bitaw class, no? So, if goal na to is i-determine kung unsay direction ani, no? Sa iyahang or ang convention sa itong graph, no? From this point to this point. So, magbase ta kang shear diagram. So, from this point also to this point. So, ato lang na siyang i-copy, no? But, since that is first degree, so, di ba, second degree na dapat ang atong MD. And, ato na siyang i-graph, no? Inward. Then, i-copy natin na siya. So, di ba, itong starting point is at 0, 0. But, na siya sa ubos, no? Ang ato ang goal is ma-obtain nato ni siya nga point, ma-connect nato siya. So, ang ato lang buhaton na class is i-mirror. Okay? So, i-mirror lang siya. So, ano siya? Sige, for points of 52.5625 up to 0.45, how do we connect them? So, in the same manner, i-copy na to, no? Starting point at this point here, and then inward. So, starting point din to, di ba, is 52.625. Ano to siya i-connect ang 45. So, tama lang ang iyahang direction, no? Kay naabot na to si 45. So, as is lang na, no? No need na siya i-mirror. Okay. Okay. So, this is second degree, di ba? Nga curve.
Very foul. So if you complete that,
So, nag-support na siya sa atong class, no? Sa atong equation bitaw sa moment. Di ba? For segment A to B, you have a quadratic equation class, no? X squared. So, meaning class, ang imuhang graph for moment at segment A to B is really curve. No? So, faktora na siya.
isa dapat isa lang ang biomechanics. Come on eh. How we look at it.
50%?
Okay, so anyway, it's already 4:25 class, no? Actually, supposedly, for this session, we will be solving 2 sample problem. But ang kaning sample problem number 2 class, actually, mas taas ang solution ani. And I think, dili na ma-accommodate sa atong time karon, no? So for the interest of time, kanilang situation number 1 ang atong i-solve. Then, we will continue our discussion next meeting. So, by the way, no, dili karong second meeting this week. Kay on Thursday, di ba, that is your CE day. So, in support, i-suspend na po ang online classes, no? Then, but we will be having asynchronous na session, no? So, sige lang, I'll post for further details. So, ato lang ni siyang tiwason. Now, for segment BC, o sa equation sa to ang moment. Diba it is 88 minus 11x. So, values of x. So, to connect our diagram, no? X should be equal to 5, no? At point B, para malocate na to siya, asa siya. So, 88 minus 11 times 5, you have 33. Okay, notice nga wala siya ni-connect, di ba? If we are to plot 33 nga moment at point B, sa segment B to C, nara siya ani nga part. So, na ay kibali mo open nga space, no? Take note nga, we have an applied moment at point B. So that actually affects the moment diagram. And then for applied moments bitaw class sa ato ang structure, ang ato ang convention ana is that clockwise rotation is positive and negative ang counterclockwise nga rotation. So napasabot nga this is counterclockwise di ba nga rotation or nga convention, so negative ang ato ang sign convention for 12 kilonewton, meaning 45 minus 12 kilonewton, that is 33 kilonewton meters, di ba? So ni-connect lang gihapon siya sa ato ang graph. Okay, so at point C, x value is equal to 8, no? So maximum value of x. So 88, so equation of moment for segment BC is 88 minus 11 times value of x nga 8, diba, that is equal to 0. So nag-0 ang ato ang moment diagram class, meaning this indicates nga sakto ang ato ang calculations, no? Sige, so graph. So follow ta ani nga convention, no? So sa shear diagram, you have 0 degree, diba, straight line, meaning at moment diagram plus 1 degree. So 1 degree na nga to ang degree, no, for moment diagram. So either of these conventions, no, or directions, but obviously will adapt decreasing since ito man na siyang i-connect, no. So there, nag-close na siya. And notice that the equation of the moment at segment BC, it is just linear, no? 11x lang muna siya class. So linear lang siya ng equation, and linear equations is just first degree na mga graph sa to ang line class, di ba? So now we have the shear and moment diagrams. Okay, so mo na siya class, no? Ang problem sa kala itong state sa problem, right? Shear and moment equations for the beam shown. So actually equations lang di ang ipangita, no? So dili necessary i-plot or i-draw, but ato siyang i-draw good to better understand the behavior. So these are our answers, class. For segment A to B, we have shear, internal shear force is 29 minus 8x. And then for moment, or internal moment at segment A to B, you have 29x minus 4x squared, no? Then, using those equations, class, no? So, makompute na to at any given point at segment A to B, makompute na to ang shear and ang moment yung magnitude. So, isa ni siya ka-advantage ni shear and moment equations nga method, class. Sige. So, for segment B to C, you have a constant nga internal shear, diba? Which is negative 11 kilonewtons. And then, for moment also, you have 88 minus 11x. Okay? So, there you go. So, if I ask po sa inyo class, if how much is the maximum moment, so that is absolute, class, no? Regardless of convention, either positive or negative. So maximum value is for moment diagram, diba, 52.5625. So that would be our maximum moment, no? Then we will be using this data to design, no, our beam. So mo na siya, class. ang iyahang importance. So maximum shear is, di ba, si 29 kilonewton. So there, we have those maximum shear and moment. Okay. So, lang siya class. So if sa board exam class no pangutanon mo, or if maka-encounter mo og problem na ipangutan na nga, what is the shear or the magnitude of shear and moment at x distance equal to 6 meters. So from point A to point 6 to distance 6 meters. So let's say for example na siya nga point mo. So unsa man nga equation ang imong gamiton to compute for the magnitude of shear and moment at 6 meters distance from a support. Sige. Anyone?
So, do you have 50%?
Wait, manawag ka. Si
Wala ko birthday ba?
Abrenica Hana.
Present, sir.
Ay, dili pa siya attendance. So, do you have an idea if unsa nga equation nato ang gamiton if ipangutan na sa imuha nga determine the shear and moment values at 6 meters distance from point A?
Ay, wait lang.
Or anyone nga na idea nga unsa nga equation ang gamiton?
Ano siya blessing na bro?
Hala, wala sila kabalo. So, naglibog ko ha if nakuha ba or nasabtan ba ang concept. Anyway, for this question class, no, so if pangutanan mo if at 6 meter distance from point A, of course, you will be using the equation for segment BC. Okay? Nga naman nga si segment BC, that is because si 6 meters, nabilang mo siya so, nabilang na siya, di ba, kang
Abi na
sorry, class.
bilisan ang 6 meters.
Again, unsa to?
5.
Again, unsa to na concern? Sorry, class, kay na ay murag events sa office, no, bibo kayo sila. Anyway, another question, Mr. Lloyd Vincent, ako nga.
Ito yung panorama.
Abi na ko lahi na sad nga diagram, sir, who. Actually, so same problem lang kanilang siya nga given problem lugar, no, and then let's say for example nga ang gi-require ani nga problem is from at 6 meter distance, what is the value of shear and moment? So of course, at di ba at 6 meters nabilang man na siya kang segment B to C. So you will be using the equations of shear and moment for segment BC. Then substitute the value of x nga si 6. So makompute mo ang pila ang moment, no, nga magnitude at 6 meter distance. So for shear, so constant lang man ang shear or internal shear at segment BC. So as is lang na siya, no? So at 6 meter distance from point A, so negative 11 kilonewton yapon imuhang shear or internal shear. Okay? So class, I really hope nasabtan or nakuha ang concept sa to ang shear and moment equations nga method. Okay, this is really very important kayo class sa to ang profession. So please do study, no? So I hope nga i-review ninyo and mag-practice mo og solve. Anyway, don't worry kay we will be having supplementary discussions pa man, no? So, sa atong upcoming nga sessions, we will continue discussing this topic para gyud nga solid ang compact gyud ang inyong foundation sa inyong knowledge class no in solving shear and moment diagrams class ha. So, for now, wala na ba questions or any clarifications or queries? Nabay pangutana?
Excuse me, sir.
Yes.
Budget lang, sir. Kaning, sir, asa gani dapit na kuha ning sir, kaning 52.5625.
Oh, okay. So, that one class, no, na-obtain na to na siya from the momental equation of segment A to B. So, asa kayo itong equation for moment of segment A to B, di ba? It is 29x minus 4x squared. Now, ang question is, how much or what value of x ang itong i-substitute? So, since at this point man ni siya, no, wala man takabalo, wala man to na siya na-establish, no, at kung asa na siya sa to ang given beam, that is why we use ratio and proportion to solve if from point A asa siya na point ba, no? So padulong na rin nga point. So that is, di ba, point distance A. So by ratio and proportion, we've discovered that from left support until 3.625, you have a zero shear. Then at that point also, dara nag-exist no, or dara nag-occur ang ato ang maximum moment.
Okay, sir. Thank you, sir. Nakuha na po, sir.
Okay, no? So, i-substitute lang ang 3.625 sa ato ang equation for moment at segment A to B. So, any other concerns or questions? Wala na? So, if you have clarifications later on, no, pag mag-review mo or if mag-study mo, you can just actually message me, no, para matabangan punta mo sa inyong mga pangutana. Okay? So, anyway, we have man-pod consultation, di ba? And wala ko nag-set og date or time sa ang consultation. So, mura siya og assuming anytime kibali ba no. But ayaw na lang po siguro ng late night na kaayo class, no. So, that is if you need help lang man po no from me. So, if di po ganahan sa ako mag-explain, so, ask your classmates na lang mga bright. Sige ha, if wala na questions or clarifications, mag-attendance sa ta before ta mo i-dismiss.
Kaya naman yung people yung nagwa. Di ba?